Okay. So we begin with the word science so that I can move forward. So as you have gone in your earlier classes, when we say science, we mean to say that it is derived from the word scientia. Scientia, okay? It is derived from the word scientia. Scientia means to know. Scientia means to know. That means to acquire knowledge. To acquire knowledge. To acquire knowledge. See, when we talk about the knowledge, every subject, every discipline talks about the knowledge. Whether you take the social sciences, they are also providing you the knowledge. They are also providing you knowledge. Whether you are talking about the humanities, you are talking about the history and literature, every subject provides you knowledge one way or the other way. But what is lagging there is the observation and the experimental factors supporting their ideas. For science, as I told you in the previous lecture, science is a knowledge which is being supported by experimentation, and observations. When we talk of the experimentation observation, there are experiments that we carry in our labs, that we carry out in our labs. For example, if you have to find out the acceleration due to gravity, you take a bar pendulum, it is hanging there, you can see. So by using this apparatus bar pendulum, by hanging it on its knife edges and giving oscillations to this bar pendulum, you can calculate the acceleration due to gravity change. You can find its value experimentally. But there are other things whose experiments you cannot perform in laboratories. For example, you are having the universe itself is a big lab, but you cannot have access to sun or access to some other galaxy, access to some other stars where you can perform experiments. You perform experiments. There you always take Earth as a laboratory. Or center from where you can carry out the observations. These observations you carry out by using large telescopes. There are ground-based telescopes. These telescopes are either of the reflecting type telescopes or refracting type telescopes, because you either use your primary mirror, or in case of the reflector, or you can have a similarly the lens type of telescopes, or you can get the refracting type of telescope. So these are what you call the ground-based telescopes. These are ground-based telescopes with the help of which you can see the motion of stars, you can see the motion of the planets, you can observe the motion of the satellites from Earth. But that doesn't mean your observations are accurate or correct or perfect. You can use space-based telescopes. That are being put in the space, like you are having Hubble's space telescope. So you are getting observations from space as well. So these instruments, these telescopes which are space-based, they can provide you more correct information regarding the happenings in the universe or in cosmos. Where you try to find out the origin, evolution of the universe, while our Earth is a very small, tiny particle you imagine in this whole universe. Okay? So, your science is knowledge about things, about you put first theories, you put forward your theories, and these theories are being supported by experimental data and observations, then it becomes science. That's why you might be you might if you go through the history, you have seen that there were so many theories put forward, and these theories were discarded because experimenters did not support those theories. Okay, for example, you are having the geocentric theory. When observationists, with the help of the observationists, we came to know that there is a heliocentric theory. Okay, so these theories are supposed to change. They are supposed to change every now and then. Okay, only that theory survives, which is supported by the experiments and the observations. So science is giving us the information about the things that exist in our universe. So this is the broad-based science that we see. Okay, you are having either biological sciences, you are having biological sciences. In biological sciences, you are having zoology, botany, and other branches of the biological sciences. When you are dealing with when your object or the particle is biological body, you try to find out the processes, whether you are talking about the respiration, you are talking about reproduction, while you are talking about circulatory system, secretory system. There are so many systems which you deal with the help of biological science. In biological science, further you categorize into zoology and botany. In zoology, you deal with what you call the science of animals, and botany is science of plants. But these sciences, these branches of knowledge, they have been explored through observations and experimentations. And other field is what you call as physical sciences. In physical sciences, you are having physics, chemistry, as well as mathematics. Mathematics as part and parcel of your physical sciences, because your physical sciences are incomplete without mathematics. They are incomplete without mathematics. Mathematics has been rightly said as the queen of sciences. It is that without mathematics you cannot perform your physics, chemistry, and even biological sciences. You need to use your logic and your mathematics to explain genetics and all the genome that has been discovered till date. Okay, so this is what we know about science. But in this science, we are having physics. Physics is our domain, which we are going to learn in this course. So when we say physics, you might have known this, that it is basically originated from Greek word, if I'm correct, from Greek word physis. Physis means nature. It means nature. Physis means nature or natural phenomena. See, natural phenomena. What is a natural phenomena? Earlier I was discussing that motion of planets around the sun is a natural phenomenon. You try to study what is the theory, what is the principle governing this motion, and how support we will put forward for this theory through observations or experiments. So when you say physis means nature, or to know nature, or to know about natural phenomena. Natural phenomena can be anything. It can be motion of waters in your rivers. Motion of water in your rivers, as I discussed in the previous lecture. As I told you, the motion of the planets. Or you can have so many examples of your natural phenomena. Even the physics is involved in the botany, where you say the water is being taken from these are the two cells, phloem, xylem, which are responsible for the capillary action within the plants. That is also a natural phenomenon. Or the signals that your brain is sending. through nervous or neuron. It is basically electromagnetic waves. So this all belongs to natural phenomena. All belongs to natural phenomena. Or you may be having in southern, north hemisphere of the earth or south hemisphere of the earth. The banks of the rivers are eroded either in one direction or in other direction. If southern hemispheres, if the banks are eroded in this direction, in northern hemisphere, then in the southern hemisphere, the banks of the rivers are eroded on one side. Also a natural phenomenon because of the Coriolis force that you may have to learn from higher classes. Similarly, you are having cyclones. This is also a natural phenomenon. So the lightning that you observe in the thunderstorms, it is because of the what you call it's a natural phenomena. You try to understand these natural phenomena, to having knowledge about these natural phenomena, then to support them with experimental facts and observations, you call it as physics. In physics, some theories may be in infancy. They might be not having the experimental proofs right now, but maybe in later years you will get the experimental proofs. For example, you might have a couple of years ago, there was in all the international media, there was a news about the God's particle, discovery of a God's particle. That particle has been discovered at CERN, European Center for Nuclear Science. Okay. So that has been detected in Large Hadron Collider there. That's a one machine there, one accelerator there, up to which we can accelerate the particle. We can try to find out the energy of that particle. So Higgs boson, it was given so many years before, Higgs boson, but it has been discovered later. So you call it as, it's a natural phenomenon that has been supported by the experimental factors. Similarly, you are having in 1924, the Einstein predicted about Bose-Einstein condensate. See, there are how many types of you are having phases of matter are there? Solid, liquid, gas, plasma is fourth, and fifth is the Bose-Einstein is condensate, one form of the matter. I will not go into the details of that because you are still in infancy of discourse. So this Bose-Einstein condensate was predicted in, I guess, in 1924, and it was discovered in only a few years back. So that means some theories have been predicted by the physicists earlier, but the people are trying to observe them experimentally. For example, you are having electroweak theory. It was given by Abdus Salam, a Nobel laureate. He has given this theory, but Weinberg experimentally verified electroweak theory. So every natural phenomenon, physicists try to. There are two types of physicists. One is what we call as the theoretical physicists. Another group of physicists, experimentalists. One who perform experiments. One are those who give theories, who suggest theories. They apply their logic, rational, and mind to carve new theories, new phenomena. Then there are people who try to find out, either try to discard these theories, or confirm these theories. These are the two things that the physicists are trying. But this physics is also categorized in so many types. One, we are having what you call the classical mechanics, and second one is modern physics. As I told in the previous lecture, that in science nothing appears from nowhere. And the modern physics or the modern technology, which is mostly based on the physics, they are basically, whether you talk of, I have told you, most of the students were absent in that lecture, whether you talk of what you call the superconductivity, an astonishing phenomena. So you are having the practical application of superconductivity existing today in the form of magnetic leviating trains that are running at a speed of around 400 km per hour. You imagine if you have to reach the Jammu, you will reach in 1 hour. You will reach in 1 hour. Imagine the speed of the car. That has been achieved by magnetic radiating phenomenon, that is the superconductors. Superconductors are basically those materials whose resistivity or resistance, they are the materials that show resist at 4.2 Kelvin. It was done performed on the liquid mercury in the experiment by Kamerlingh-Onnes, that he found that at temperature of 4.21 Kelvin, liquid mercury shows no resistance at all. You imagine the conductors. Nowadays you are supplying electricity is being supplied through what you call the aluminum wires or copper wire. Aluminum is a conductor of electricity, but not as good as copper. But copper is costly, we are not using it. And then silver is the better than copper, better than in terms of the conductivity. But we cannot use silver, it is costly. Then gold is the best conductor of electricity, but you cannot use it. So even the richest country in the world, they cannot afford to have gold wires to transmit your electricity so that you can minimize the loss of the power. So they cannot use gold wires. So if you imagine you are using a superconducting virus. So that means if your resistivity becomes zero, your conductivity becomes infinite. Your conductivity becomes infinite because they are having inverse relation. That way you can imagine how much power you can save. Otherwise, most of the power that is being generated is getting wasted through transmission line, because these are poor conductors of electricity. The transmission lines that are using, they are being used only because of they are cheaper. Similarly, you are having the energy crisis are looming all over the world. So people are trying to do most of the research in energy, so that they can attain and achieve new forms of energy, through which your life can become much more easy and comfortable. There should not be burden on those fuels that cannot be that are not renewable. What I mean to say, people. So that's why you are learning that, we are having one accelerator. You might have gone through cyclotron in your earlier class, 12th class. You are having Van de Graaff generator. The aim of those machines were to accelerate the particle. Once you are accelerating particle, you are trying to achieve higher and higher energy. Your Van de Graaff generator was giving 10 million electron volt energy. That's a pretty large energy. But you are trying to find out the accelerated particle so that you can achieve the energy in giga electron volts. Giga electron volts is a tremendous energy you are trying to achieve. You are trying to achieve with the help of these new machines. But these new machines are because of modern physics. That the basis of this modern physics is quantum mechanics. You might have heard the quantization of energy. Earlier you said that energy is having a continuous spectrum. But Planck, when he gave the Planck's blackbody radiation law, he found that energy is quantized. So it is in discrete levels or bundles. Just like you are having, if n is equal to half of h nu, n is equal to 1 for hydrogen atom, n is equal to 1, 3 by 2 h nu. Even at absolute zero, energy is not zero, it is 0 point energy. It is 0 point energy, which you call as half of h nu, half of energy. This is basically before 1905, physics was said to be it was categorized as a branch of philosophy. It was not a separate branch physics. After 1905, when the quantization of energy concept came into existence by Planck, so the physics it evolved as a subject. Because see, in philosophy, why it was a part of philosophy? In philosophy, suppose something is hanging there, you will try to find why it is hanging, how it is hanging, for what purpose it is hanging. In philosophy, you ask questions. You ask questions: how, why, what, when. So you ask so many questions. So that means you try to find out the logical answers to the problem. So that is why how the physics started in 1905, and Planck, then came the Einstein. He gave special theory of relativity. Then he gave the photoelectric effect that completely revolutionized physics. So on up to 1960, it was a golden era for physics. Then onwards, we were having the computer age in 1980 onwards. Nowadays, we are having artificial intelligence. Artificial intelligence that is now taking over all other subjects. Similarly, you are having what you call the nanotechnology. That means you are manipulating things at atomic level. Suppose this is 1 meter rod, you cut it into 10 to the power 9 times. Of the order of 10 to the power 9 you cut into. You are having 1 meter rod, you divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So how much smaller the thing will be? It will be of the order of atomic dimensions, because dimension of atom are 10 to the power minus 10 meters. But nano is 10 to the power minus 9 meters. It is nearly equal to atomic dimension. That means if you cut a things at nanoscale level, so you will see the objects that appear as a bulk, as opaque objects, for example gold, they will appear as transparent. And their electric and magnetic properties dramatically change. So if you make such a material that is made up of the nano materials, then you can utilize in nanomedicine, where you can supply a drug to a cancer patient, where it can only target, through nano case, it can only target a cancerous cell, not the healthy one. Similarly, in fertilizers, you can use nano fertilizers, so that your yield and crop should increase manifold. Similarly, for water purification, you can use nanomaterials to purify the water and kill germs and all that. You are using these buckyballs, you are using long tennis rackets, so that their life will increase, or the shoes, so much will come. But all the things that I am explaining, or you talk of the astronomy, where you try to explore the cosmos, pulsars, try to find out the peripheries of the universe. So these are all basically because of the classical physics. Classical physics का मतलब है, it means the Newtonian physics. It means Newtonian physics, and it started when Newton has given his famous 3 laws of motion. These are the foundation and the basis of your classical physics, on which whole Newtonian physics is based. In his famous book, The Mathematical Principles of Natural Philosophy. So he has borrowed the idea from the Galileo. So he discovered these 3 laws, and because he was a genius, and he developed a calculus. See the object varying with respect to other object. For example, if the average depth of a stream is 5 feet, and this guy is a 7 feet tall, so I am sitting at the bank. Can I say that he will cross this river easily? But there are chances he may get drowned in this stream. Why? Because it is the average depth. The depth is from point to point. So you are having the variation of one variable with respect to other from point to point. If I am dropping a pen from this point to this point, what is the change in velocity with time at this point, at this point, at this point, at this point, till it reaches the ground, till it reaches the. So he developed calculus, differential calculus, differentiation, which you call in more lucid language. So similarly, Leibniz at the same time he also developed calculus of higher orders to try to solve the problems that are in your physics. Similarly, you are having thermodynamics, where you are dealing with the dynamics is something related to motion. So due to thermo is heat or temperature. So what are the phenomena that are involved by heating an object? You try to explore those things. See, thermodynamics is perhaps the only branch in physics where you can almost explain everything through experimentation. Everything through experimentation. So then you are having electrodynamics in physics. So electrodynamics is where you are trying to find out the electricity, magnetism, and the relation between the two, electrodynamics. Because of the Faraday's law of electromagnetic induction, changing magnetic field produces electric field, changing electric field produces magnetic field in turn. So these are basically how physics evolved. But I was discussing about modern physics, about quantum physics, while we were trying to find out the behavior of the particles using quantum laws of physics. That provided the basis for your modern physics or the modern technology, because you are having mobiles. So your semiconductors are used and applicable everywhere. So you are using semiconductors in your phones, your laptops. Everywhere you are dealing with these type of materials. Silicon or germanium. They are the semiconductors whose conductivity lies in between that of the good conductors and bad conductors. And the beauty of semiconductors is that when increase in temperature, their conductivity increases. Are you getting my point? So you are employing silicon or germanium and other types of gallium, other types of semiconductor material to produce chips. First you produce diodes and transistors. Then you started with FETs, MOSFETs, then integrated circuits, op-amps, so many applications. Then you are having all your modern this gadgets are made up of the electronic gadgets are made up of the semiconductor technology because of the advantage it is having. Because silicon is the very cheapest material. It is in abundance on earth. So you can easily employ those because of its good these properties, electrical properties, as well as because of its cheapness. You can employ this. Now, then question arises: what is physics in relation with other sciences? Physics in relation with, that's in your syllabus. That's what I am talking. Physics in relation with your other sciences. For example, you take the first example of your biological science. So you are trying to observe a cell, animal cell, with the help of which you can observe this. Microscope. In microscope, what you use? You use lenses. So how to prepare a lens of having a good magnifying power, good resolving power? Do you know what is resolving power? How to resolve two closely lying objects. For example, if you look at a star, it appears a single star at night, Sirius A and Sirius 2. But if you look at a through telescope, it will be apart. There will be two stars actually. But the resolving power of our eye is very weak in comparison to the telescopes that we are using. So we cannot separate these two objects. So this microscope is having very good resolving power, high magnifying power. You are observing biological science, or you are using electron microscopes, where you can get the minute level tak aap chale jate ho. Or you can use MRIs, where you are having a superconducting wire that is being freezed by liquid helium, so that with the help of which you can take images. There is basically it is based on how protons behave in our body. So proton spin. So I cannot go into the detail the magnetic resonance imaging this time. So these are all the gadgets. They are basically the mother of these gadgets is physics. So you are having computers. In computer you use motherboards, you use so many electronic circuits. So you are basically employing what you call the physics there. So it helps us in biological science, or you are having biophysics. So while you are trying to correlate your physics with the help of with your biological processes, how the processes within the humans or within the animals they take form, what is the connection of the physics with biology. For example, I have taken you the signal sent by the brain. So you are saying in terms of physics a electromagnetic signal. So electromagnetic range starts from gamma rays. Gamma is the highest energetic particle. Then you are having X-rays, highest energetic particle. Then you are in ultraviolet rays. Then you come down visible, then and so on up to red and microwave and so on and so forth. Okay? So this is the electromagnetic spectrum. So you are saying that you are trying to study how the biological processes take place by applying physics. That's what you try to find the physics behind the biological science. Rather, I should use the statement how physics is applied behind the biological process, whether it is a circulatory system, whether it is a what you call the heartbeat in the circulatory system, or your digestion, where you chew food, then oxidation and all that. So there is physics involved some way or the other way. Or to take the botany, I give the example of this what you call the physics, or some botanists say that plants do also communicate. They also send signals to other plants. So this communication is why they use the physics is there. The physics is there. So this is in relation with biological science. Now take in relation with mathematics. Mathematics is the backbone of physics. So, but we physicists say, mathematicians say Newton was a mathematician, but we say he was a physicist. He has contributed to mathematics. Similarly, other scientists, Gauss, other people, they have basically contributed to mathematics. Okay? Are you getting me? So mathematics and physics are correlated. Even mathematician, if a cow is on a mountain, so if you ask a ordinary person belonging to some other stream, he will say cow is there. But if you ask a physicist, he will say cow appears brown to me. But if you ask that question to a mathematician, he will say cow appears brown on my side. The side that it is facing towards me. So that is the importance of mathematics. So all the calculations that you are drawing, whether you draw the models of the universe, how universe evolved, how it behaved, you are using huge mathematical equations, tensors you are using geometry you are using there. So because see, gravity, what is gravity? You say it's attraction, I say it is because of geometry, because of the curvature of the space. So you are having gravitation because of if you somewhere is a hole, all the objects that will start moving around it. Are you getting my point? So gravity is because of the curvature of this space. It is because of the geometry. That is in the relation with mathematics. We have discussed it what is science. We have discussed what is physics. We have discussed it as few branches. Then we have discussed it in the relation with biological sciences and mathematical sciences. Now, you can take what you call as in the relation with chemistry. What is the relation of physics with chemistry? Can you tell me? You are having a physical chemistry. Physical chemistry involves physics. It involves, see, the period, what's called this periodic table. The periodic table has been devised on Moseley's law, which is based on atomic number, square root of atomic number. So on the basis of you arrange the elements in your periodic table. So it is you are having the physics applicable in your chemistry, where you are trying to find out the reversible processes, irreversible processes, entropy. Then you discuss so many liquefaction of gases, helium, liquefaction of mercury, liquefaction of hydrogen. So these are all correlated with physics. Physics helped in chemistry. Chemistry in return also helped in physics. This is because there is an interdisciplinary world. You cannot remain aloof. So everything is coordinated. So it also helped out in chemistry in many ways. So shall I stop here or shall I move further? Time is over. Okay.